Imagine hiring a genuinely brilliant assistant for your business,
Okay.
but every single morning they wake up with total amnesia. So you spend 20 minutes retraining them entirely from scratch.
Right, just so they can do, like, basic tasks.
Exactly, and that is exactly what manual prompting feels like today. You type a complex prompt into the interface, you wait for the machine, it makes a mistake, so you fix the instructions.
Yeah, and then the very next day, you start over.
You type that exact same prompt again from scratch. I mean, it is a universally frustrating experience.
It really is. You essentially become like the manual operator of the software.
Yeah.
You are constantly running a machine that really should run itself.
Well, welcome to the deep dive. Today, we are unpacking a truly fascinating shift. We are exploring intelligent AI automation loops with Claude Code.
It is such a cool topic.
It really is. Our mission for this discussion is very simple.
Yeah.
We are moving from manual operators to system builders. We want systems that systematically check their own work, and learn deeply from their mistakes.
Right, because it is a massive shift in your entire working perspective.
Yeah.
You completely stop babysitting the AI through every single step. Instead, you build a robust process that runs autonomously. It actively checks its own results against your specific goals. And it remembers the vital lessons for the next time.
Let us look at a concrete, real-world example of this. Consider Anthropic's own internal growth marketing team. They have one single person running their performance marketing.
With absolutely no technical background at all, which is wild.
Right.
They manage paid search, paid social, and app stores. They also handle, complex email marketing and massive SEO campaigns. One person manages that entire massive workload alone.
I mean, doing that manually requires an impossible amount of time.
Completely impossible. But they built an intelligent workflow to handle it. The system automatically reads a heavily populated CSV file.
Okay.
That file contains hundreds of old, historically tracked ad samples. The system carefully finds the specific ads that are underperforming. Then, it dynamically generates entirely new versions of those ads. It even perfectly fits the exact character limits for each platform.
Manual prompting is kind of like stacking Lego blocks of data. You pick one up by hand and carefully place it. It takes your active, undivided attention every single time.
Yeah, absolutely.
But building an automation loop is fundamentally different. You are engineering a custom machine for your specific workflow. That machine actively snaps the data blocks together for you.
That is a perfect way to visualize the transition. And the real-world results they saw are absolutely staggering.
Oh, really?
Yeah. Before, their ad copy creation took 2 hours per round. Now, that exact same process takes just 15 minutes.
Wow. 2 hours dropped down to just 15 minutes. That fundamentally changes how a marketing team actually operates.
Their creative output tested across various channels increased 10 times. They used 2 highly specialized sub-agents for this specific workflow.
Sub-agents meaning specialized software focused on one specific job? Right.
Exactly. One sub-agent focuses entirely on writing the optimal headlines. The other sub-agent focuses entirely on writing the detailed descriptions. Together, they generate hundreds of new ad variations in minutes.
But the pure speed isn't the real magic here. The real magic is how the overall system actually learns.
Right. The system carefully logs operational hypotheses during every single round. It also tracks the concrete test results across those rounds.
So it remembers.
Yeah, the system builds on that historical data completely automatically. It intelligently uses that data to perform better next time.
So quick question on that. If a system generates ads that incredibly fast, what stops bad optimization?
Well, it is strictly bound by the historical logs it consistently creates.
Right.
It checks new ideas against recorded failures before outputting anything.
Past failures become strict boundaries for all future ideas. To build this self-improving system.
You first have to know if your specific daily task even qualifies for a loop.
Right, the filtering test.
Yeah, that is a profoundly crucial point to understand right now. Not everything deserves a highly intelligent, complex automation loop. We had a strict filtering mechanism before building anything. We have a foundational test featuring 4 specific conditions.
Let us walk through those 4 filtering conditions together. The very first question is incredibly simple. Does the specific task actually repeat itself regularly?
Right. If the task only happens once, stop right there. A standard manual text prompt is more than enough.
The second condition is where it gets really interesting. Is there a remarkably clear definition of done?
An automation loop needs a finish line it can recognize. It needs to securely recognize that line entirely on its own. It cannot rely on a vague, subjective human feeling.
I want to offer a gentle pushback right here, though. I think people might massively overestimate what done actually looks like.
Oh, definitely.
We often think our own jobs have clear, objective finish lines, but they really rely on incredibly heavy human intuition.
That is exactly why objective definitions are so incredibly critical. Let us look at a great example from Anthropic itself. They have an internal feature simply called code review.
Okay.
It checks software code automatically before it merges into the product. This specific task repeats constantly throughout the entire working day. Dozens of new pull requests show up every single day.
So how do they define done without human intuition?
For them, done clearly means finding objective bugs in the code. It also means ranking those specific bugs by their technical severity. It isn't just asking the AI to generally skim the document.
Right. That is a perfectly clear, objective standard.
Yeah. The third condition is strictly about the resources involved. Can you comfortably accept the financial cost of the automation?
Because loops run through multiple operational steps to finish a job.
Exactly. It isn't just the single, simple, inexpensive text reply. Those multiple processing steps add up fast in compute costs. Anthropic has complete financial transparency on this specific condition.
What are the numbers?
Each code review costs roughly $15 to $25, and it takes about 20 minutes to entirely finish running. Anyone using it knows the exact computational price upfront.
So there is absolutely no guessing about the final server bill.
Right. And the fourth condition is about the system's actual capabilities. Does the loop have the necessary tools to finish the work? More importantly, can it strictly verify its own generated results?
The verification tool for their code review is quite fascinating, actually. It uses several parallel AI agents analyzing the code together. They cross-check it against the surrounding code in the main repository. They objectively confirm the bug is real before reporting it.
That is exactly why it is worth turning into an automation loop. It perfectly meets all four of our strict filtering conditions.
The general rule of thumb here is quite brutal, honestly. If your task misses even one of these four conditions, stop. Do not force it into a complex automation loop.
Right, and a normal manual prompt works perfectly fine then.
So what happens if you build a loop without a clear definition of done?
The system will simply run endlessly in the background. It will burn through your server budget without ever reaching a conclusion.
Vague goals create infinite loops that destroy your budget. Once passing the test,
We need to assemble the actual machine, which is made of 4 distinct parts.
let us deeply explore each of those 4 fundamental parts. We have the trigger, execution skills, goal and verification, and finally, output and memory.
Breaking down the core mechanics is essential for system builders. A successful loop works because these 4 specific parts fit together perfectly.
The trigger is basically the starting line for the entire loop.
Right, without a recognized trigger, absolutely nothing fires in the system. You are right back to typing standard text prompts by hand. Claude Code gives you 3 distinct ways to set your triggers.
Each specific trigger fits a very different type of working situation. The first trigger is simply the forward/loop command.
Yeah, that command runs right inside your active, open working session. It is really exceptionally good for quick, short-paced operational checks, but it immediately stops the moment you close that specific session.
Or it automatically expires after 7 days.
Exactly. The second trigger option is widely known as cloud routines. This one runs entirely on Anthropic's own remote servers. It isn't tied to your local hardware machine at all. You can completely close your laptop, and it comfortably keeps going.
That makes it totally perfect for overnight intensive background tasks.
Or for generating a complex report at a strictly fixed time.
The third trigger option is directly called desktop tasks.
This trigger runs quietly in the background, right on your machine. That essentially means it can reach your local files directly. But your physical computer must stay fully powered on for it to run.
Okay, so we have our trigger properly configured to wake the loop. The next crucial part is the actual execution skills. This is where the real computational labor finally takes place.
The system intelligently uses parallel agents looking for different issues simultaneously.
And an entirely separate step then mathematically checks those findings automatically. Actually, I need to ask a clarifying question about the execution step here. How exactly do parallel agents differ from a single chat window?
Well, a single window processes sequentially and frequently drops vital context. Parallel agents are separate programs working simultaneously without losing their specific focus.
Parallel programs analyze issues simultaneously without losing context. Now, how do we...
Guarantee it doesn't just confidently do the wrong thing really fast.
Exactly. We'll get into the secret sauce right after a quick break. Mid-roll sponsor, Read Placeholder. And we are back, ready to deeply explore that secret sauce. A clear goal is completely useless without a robust verification step.
Anthropic definitely found undeniable proof of this while building Claude Code. Verification skills consistently made the absolute biggest difference to output quality. It heavily mattered more than absolutely anything else they tried building.
Telling Claude to simply fix a bug is definitely not enough. That vaguely gives a general direction, but no way to actually check it.
Exactly. Think about checking an online, functional e-commerce checkout flow. You don't just briefly tell the AI to quickly fix it.
Right.
You cleverly have it use test credit cards during the execution. Then, it physically confirms the generated invoice lands in the right database. It actively verifies the end state before ever claiming it succeeded.
You actually have 3 incredibly practical ways to build verification steps. The very first is a perfectly simple pass or fail script.
There is absolutely nothing for the AI to interpret or guess there. It strictly either passes the written script or it completely fails.
The second verification method is a specialized second pass AI skill.
This actively functions like a strict inspector on a factory assembly line. It rigorously checks the first AI output before anything actually ships.
The third verification method is a remarkably strict scoring rule. The AI objectively rates its own generated result against a pre-written standard.
If you entirely skip this vital verification part, you have a massive problem. Your automation loop will confidently report success even when absolutely nothing got fixed.
That immediately leads us directly to the profound concept of memory. Output is simply what you visibly see after the loop finishes.
Right.
It might realistically be a newly generated file or a permanently fixed bug, but memory is the critical part most people completely skip over.
It is definitively the most vital, foundational step in true AI automation. Without proper memory, the loop acts like a person with severe amnesia. It knows absolutely nothing at all about the last automated run.
It can stubbornly walk straight into the exact same failed paths daily. I actually have to admit something quite vulnerable right here. I still wrestle with prompt drift myself.
It happens to the best of us.
It really does. That is when the AI slowly forgets its original instructions over time. Getting it to stay on track is really incredibly hard. Doing it without these memory safeguards feels nearly impossible sometimes.
It is incredibly deeply frustrating for everyone who casually tries it. Anthropic ran into exactly this painful problem with an internal science project.
Oh, really? What happened?
A senior researcher had Claude build a highly complex numerical formula. This intricate project took many consecutive days to complete, not one sitting.
To keep the AI from aggressively repeating old mistakes, they adapted. They brilliantly had Claude automatically write its own detailed progress file.
That historical file tracked 3 very simple, incredibly important operational things. It thoroughly tracked what was already successfully done by the AI. It tracked what was actively currently being worked on. And crucially, it meticulously tracked which mathematical approaches had already failed.
That final documented part is the real true job of memory. It completely stops the next automated run from wasting highly expensive compute time. It forcefully prevents the system from trying a historically known dead end.
There are a few very simple ways to properly format this memory. You can utilize a basic log file that records what recently happened. You can maintain an entirely separate file exclusively listing what failed.
Or utilize a short note. Claude dynamically writes, summarizing the recent code changes. There is also a highly specific architectural file directly called keyallUEE.md.
Right. That specific markdown file holds all the absolute specific project rules. Every single time a new code review runs, the system reads that file.
So if the newly proposed code breaks a written rule, it catches it immediately. Absolutely no one has to constantly repeat the foundational rule to the AI. Let me ask, how does the loop actually know to read the file before acting?
The underlying code strictly requires the system to ingest that specific file's contents into its context window before generating new output.
The script forces the system to load historical context first, armed with memory.
And verification to ensure quality. We are finally ready to build step 1.
This is exactly where we put everything into real, practical action. We have a straightforward 4-step guide to reliably building your first loop. We strongly want to start extremely small and scale up safely.
Step 1 is carefully picking a remarkably small, consistently repeating task. It really should be something you already know how to do manually.
Definitely skip successfully automating the entire whole workflow for your first try. Pick something incredibly tight where you know exactly when it is genuinely done.
Step 2 is actively using an execution skill you already deeply trust. Run it manually by hand a few distinct times first to thoroughly test it.
Strongly hold off on putting a totally untested skill into an automated loop. You desperately want to logically ensure it works before you automate it.
Step 3 is carefully packaging it into a comprehensive, full skill. A truly reliable skill carries a very clear, objectively defined goal.
It needs a remarkably concrete way to verify the final generated result.
And it critically needs a robust contingency plan for when something goes wrong.
Step 4 is the crucial one most people get entirely backward. Start highly supervised, then slowly, methodically move to fully automatic execution.
Anthropic distinctly observed this specific pattern by tracking their own users. Brand new users strongly tend to manually approve every single AI action.
They watch it incredibly closely before letting it take a subsequent step.
Highly experienced users operate completely differently with their established loops. They comfortably let Claude run many complex steps in a row automatically. They essentially only step in when human intervention is actually truly needed.
You should logically follow that exact same cautious path with your loop. Run it highly supervised the first few times you actively try it.
Check the generated result incredibly closely at each individual operational step. Turn off the active supervision only after seeing it flawlessly succeed multiple times.
If your task still feels vaguely defined, comfortably hold off on looping. Break it entirely down into smaller pieces and add a clear middle checkpoint.
Whoa! Imagine scaling to 1 billion queries. If you magically get this entire architecture right, the ultimate leverage is unbelievable. You could literally scale autonomous loops across an entire company's workflow.
When you are supervising the loop, what specific signal tells you it is safe to switch to fully automatic?
You fundamentally need a track record of complete unassisted consistency. It must successfully complete the task and pass verification 3 consecutive times.
3 unassisted verified successes means you can completely automate. We have gone from manual prompts
Overseeing an automated machine.
That naturally brings us to the core fundamental takeaway of this discussion. We are actively witnessing a deeply profound fundamental shift in how we work. It isn't just about repeatedly retyping manual prompts every single morning anymore.
It is thoroughly about building a beautifully robust, completely self-sustaining system. A customized system perfectly complete with historical memory and strict verification protocols in place.
A system that reliably keeps important work moving entirely on its own.
You systematically transition from being the exhausted operator to the brilliant architect. You elegantly design the logical structure, and the AI tirelessly executes the labor.
I really want you to consider your own daily workflow today. Look closely at the most annoying, highly repetitive digital chore in your week right now. Is it actually genuinely too complex for an intelligent AI to handle? Or is it simply just missing a clear definition of done and a memory file? That is the absolute essential foundational question for anyone actively building these systems. It forces you to beautifully clarify your own actual work processes entirely. Thank you deeply for joining us on this fascinating deep dive. We highly encourage you to eagerly experiment with your very first small loop today. Define the objective goal, precisely set the verification, and carefully test the waters. Until next time, keep exploring and stay curious.